working. This is working. Excellent connection. That's what I like to see. There they are. Okay, final few entries here. Let's see, I don't have Andre, Christian, or Angel. That's a lot. We're missing 3 people today? That's unfortunate. All right, well, I guess we'll just have to say hello over YouTube later. Well, good afternoon, everyone. Welcome back. Hope you had a good break. Oh, there's Andre. There's always one right afterwards. Okay. There he is. Today, we're gonna start moving some mountains, okay? But don't worry, we'll just a little bit at a time. We've got our final topic for the semester, circles. Okay, we covered some very basics of circles way back early on in the semester. You know, radius and diameter and pi r squared and that simple stuff, right? So now we're going to take a closer look at some fun, unique sort of properties that can come about from circles. And today, we're specifically going to look at tangents. What happens when you draw a tangent line to the circle? Okay, so, before going in there, quick vocabulary review to make sure we're all on the same page. When I say a word, you have the same picture and idea in your head. Let's run through these real quick. Give me your answer in chat. From the images and selected names of things on the side here, which letter, A through J, best represents congruent circles? Okay, we're going to start with number 1, congruent circles. Give me the matching letter. Go ahead and type it into the Zoom chat. Single letter. Where is the congruent circles? Yes, that is correct, Litzy. Good job. Marichelle's got it. Excellent. We're 2 for 2 so far. Gonna have to remember what congruent means. Leo's got it. Very good. That's 3 out of, it says there's 8 in here, but that's counting me. I have 7. Oh, nope, there's number 8. Hello, Christian. Welcome to here. Christian, we are matching up number 1 on my screen. Can you find which lettered item here represents congruent circles? Tell me in the chat. Three of 8. I need 5 more answers. Ooh, close, Christian. E is actually concentric circles, right? These are concentric circles because they share the center. So you got this one and that one at the same middle. They're concentric. They are not congruent because congruent means both the same shape and same size, right? And one of them is clearly bigger than the other. So find me a set of same-sized circles. Jose Luis has got it. Good job. There you go, Christian. You found it. Who am I still waiting for? Gina, I need an answer. Jocelyn, I need an answer. Got one. Andre, I need your answer. There we go. Good job, Jocelyn. You guys didn't expect to start with a participation question. What do you mean I still need to reach my keyboard? And the others? I'll give you one more minute. Still waiting on an answer from Gina. And what else? And Andre. Gina and Andre, your answer to congruent circles, please. All right, I guess you're just not here. Okay, that's fine. We'll go on without you. The correct answer, of course, is F. These two right here are the congruent circles. They are the same size. Both have that 3-inch indicator for the radius there. Speaking of a radius, that of course goes from the center to the outside. So if you had to name one, you would find that would be something from this diagram here, something from O, OA, OE, OB, could be any of those, the one on the list there. C, O to E is a radius. We've got a chord. Can we find the chord? That's the next question. Find me the chord on this list. Number 4. Type me the letter in chat that indicates the name of the chord, which A through J gives me the name of a chord here. Marichelle on the ball with the first answer, and correct one too. Leo's got it. Jocelyn's got it. Litzy with even more question marks than last time, but still correct. Very good, Litzy. Jose Luis, that is not correct. Unfortunately, save that guy for later. Remember, a chord goes across a circle and touches at 2 points. It's a segment inside the circle that hits at 2 points, not necessarily through the middle of the circle. got it yet? We're still only halfway through. Come on, folks. We're never going to get anywhere at this rate. D, ooh, I'm glad you brought that up. Okay, let's look at D. D is segment AB here, A to B. Yes, that is technically a chord. This is a segment that goes from one side of the circle and touches another side. It's also more specifically a diameter, okay? So while you are correct, you could match up D and say that is a chord. It would be better classified as a diameter because it's a little bit more specific. So we're trying to see really, and this is one of those guess what the teacher's thinking kind of questions. Like, yeah, okay, technically correct. But the better answer, if you were matching all of them at once, you'd use this one for diameter because you had to have that on the list. And so the only one left that's only a chord and not also a diameter would be this segment DC here, which is letter A. Okay? So A designates the chord. 5, the diameter is A to B there. Option D is indicated. And our special guest today, the tangent. I'll go ahead and give this one to you. That's this guy right here, line TG. Option B. And it's a tangent because it's a line that touches the circle at exactly one point. That's what tangent means, to touch. And it nicks it just that one spot, nowhere else. Okay? And there's several unique consequences of setting it up and specifying. No, you can only touch in one place. Let's see what some of those are. Okay? So our tangent properties. These show up a lot in some kind of example like this. Right? We've got our circle and our lines set up here. This is a pretty common setup. We've got two tangent lines, in fact. So this line TA, or actually ray TA, is tangent to the circle there at A, and ray TG is tangent to the circle there at G. This is circle N. We've got two radii drawn in here. So, and this major arc out here is given as 220 degrees. They want us to find the measure of angle T. That's this one right over here. And as far as application goes, you see this a lot they love to throw the satellite around the Earth kind of question. Okay, this is the Earth, and you got the satellite here, and what's the signal strength to two different radio towers on, two locations of the Earth, or something like that, right? Or another possibility, again with the space theme, this could be a setup for an eclipse. Talking about the shadows, like imagine this is some object casting a shadow onto planet Earth. It's like this much is in shadow, but this part isn't covered. I also think about visual. This is, if you were to look at a ball, right? If your eyeball is over here and the ball's over there, and this is how much of it you can see at once. Right? It's between those two tangent points. So the tangent lines to a circle, right, comes up quite a bit. There's lots of different applications for this. So let's see what we can do here. We know that this arc is 220 degrees. We know that all the way around the circle is 360. So we could do a simple subtraction. We could get this minor arc right here, right? Just take 360 minus the 220. 0 minus 0 is 0, 6 minus 2 is 4, 3 minus 2 is 1, 140. Right? So that arc right there is 140 degrees. And since this is made of two radii, this is a central angle. And if we recall, when we first looked at circles this year, the central angle, an angle formed by the center of the circle as your vertex, is equal in measure to the arc that it intercepts. So if the arc is 140, then this angle is 140 degrees. That's kind of interesting. It at least faces like across from angle T. I don't see how that really helps us get there directly. We need more information. What else can we determine about this tangent line and its relationship to the circle? I've drawn in the radius is already there. You know what this almost looks like? What do you think this angle is? What would you guess? If this was pop quiz, multiple choice, what would be like your first instinct? Oh, I've got to go with a good common geometry answer. Okay. Marichelle's got it. Like, if you had to give that a number, what's your instinct tell you that's going to be? I think you guys can get this. We don't want to rely on the diagram. I'm not saying that. I'm saying I bet you can figure out, you can predict what the rule is going to be. Litsy's got it. Marichelle converting back to a number. Yeah, that works. What kind of angle do you think is going to be? See a few more predictions here. We've got a real short list of good numbers worth guessing in geometry. If we're ever asked to guess an angle measure, anything measured in degrees, 45 is a good one. 45 would be on that list. That's not it this time. It'd be 45, and then multiples of 90, 180, 360. Those are like our top 4 numbers of degrees on anything, right? How many times has the answer been 180? How many times has the answer been 90, 360, right? Like, those are super common. Which one does this look like it's got to be? Of that set, right? Only one fits the size of this, even closely. Like, it can't be 180. That would be the whole line here. I need a few more predictions here. I can't just be giving away the answers. That's boring. Tell me what you think it is. No, bigger than that, Jose. Don't just throw anything out there. We've got a specific list, right? 90, 180, 360. Which one do you think? Of those, what has it got to be? It's not going to randomly be something else. We're looking for the rule. What do we think the general rule is here? Every tangent line meeting that radius. An acute angle. It's not, though. It's not an acute angle. But it's not obtuse either. It turns out that that is going to be a perfect right angle every time. It's a bit unfair of me. I know. I say don't rely on the diagram. Don't just go by what it looks like. That's true. I was hoping you guys could remember either from your notes or make a prediction here. What is the general rule? And the rule is that tangent lines are always perpendicular to the radius drawn at the point of tangency. So wherever the tangent line touches, that's the point of tangency. If you draw the radius of the circle to that point, it will always meet perpendicular to the tangent line. So that's a 90-degree angle, and that's a 90-degree angle, which is really convenient when you think about it. And if we really analyze this, if you think too hard about it, it must be true. Think about this. If I were to take that line and try to turn it a little bit so that that angle is less than 90, and we'll move it back so it still runs through that spot. It's now no longer only touching at that spot. It's going through the circle also up here. Right, let me make that more extreme. You can clearly see, right, if it was to hit here and it's not a 90-degree angle, it's going to pass through the circle somewhere else as well, and therefore, by definition, no longer be tangent. So to be tangent, it must make a right angle exactly a right angle, nothing else. Which means we now know three angles in this. Hey, that's a quadrilateral. Look at this right here. We know a little something about the interior angles of a quadrilateral, right? They should all add up to 360 degrees, right? A triangle adds to 180. Quadrilateral is 360. So if I subtract off that 140-degree angle and the two 90s, what's left has to give me the measure of angle T. Right? What do we get? Do the math for me here and put your answer in chat. Let's see, you are correct again. Very good. Jose Luis, now you've got it. See, that's where that number came from. You were just getting ahead of me. Yeah, that leaves you with 40. So this must be 40 degrees, right? That's kind of nifty. I like this question. It brings together circles with tangents and arcs and central angles and, hey, throwback to quadrilaterals. Speaking of quadrilaterals, there's one more interesting property from the tangents. The fact that we have two of them here, and maybe you can guess this from the quadrilateral itself. What type of quadrilateral does that look like? Does anyone identify a more specific quadrilateral that this seems to fit the properties of? We've got two angles are congruent. We've got a pair of angles that are supplementary. We've got a pair of congruent sides here. It's not a diamond. Diamond is not one of our math terms for the shape. Let's see again, spanning those question marks when you're correct. It is a kite, right? Isn't that like the classic, put that on a string and go fly it outside on a windy day? Perfect kite right there, absolutely. Tetrahedron is a three-dimensional shape. Tetrahedron is a three-dimensional shape. We'll get more with those next semester, all right? Yeah, this is a kite. And because it's a kite, we know that those are congruent, and we know that because they're both radii. And the other pair of congruent sides would be right here with that kiteness to it, which means these tangent segments are themselves congruent. So that's point number 2. Two tangent segments from the same point are always congruent. That's a neat feature. Sorry, my picture is there in the way. It turns out wherever this point is, somewhere out in space off of the circle, if you draw your lines tangent to the circle, it's always equidistant. So it doesn't matter which side of the planet you head back towards, it's going to be the same length of trip. Okay? I think that's kind of an interesting result. Not necessarily intuitive. I mean, if you look at it, like, yeah, that seems reasonable, but not immediately obvious that it's necessarily the case. But it is. They're always congruent. Right? So those two facts alone should be enough for you guys to tackle, plus all your other prior information on triangles and quadrilaterals and such, to tackle exercises 1 through 6 on today's worksheet. They get a little bit more involved. Notice 2 brings in, two circles sharing a tangent line. Oh, man. You got to go from one to the other. That's okay. Look, they're connected right there with a little vertical angles bit. Don't let that throw you too much. Some good questions combining things here. The number 7, though, go ahead and cross out number 7. Number 7 involves constructing a circle. We're not doing constructions this semester, so you can skip number 7. But 1 through 6 you can totally take care of. Anyone have any questions at this point? No? All right, then I will leave you to it. You've got the rest of the period to work.